tangent of the half angle substitution. Tangent of the half angle substitution. Now, yeah, that's it. That's it. That's the whole issue. Now, this is one technique under this course which is most important. It's very, very important. It's very, very important. All right. So let's look at that. Let's look at that. Now, you have to bear in mind that this is not the same as the one that we have solved previously. You know how you have search in that form. Search form is not the same as what we are doing. So you need to compare these two things and know what to do in case you get search questions. All right. So that is that. We have our right angle triangle, and this represents the hypotenuse, the adjacent, and the opposite. But don't forget that whenever in the question we have the angle to be just, let me say, if we have the argument to be theta, just theta or x or something like that, we use the half angle. So this is the half angle idea, all right? There are some questions that you can get here to be called half theta. If it's half theta, then you use theta over 2. Sorry, theta over 4. That is quarter half angle substitution. That's what we are going to do. So with this person, we are going to use the half angle, all right? And when we get to the next, which is the question 2, that is when the case that we have the argument here to be half of that angle. When you are taking half of that angle, then it seems to be coming from this idea, even though it is similar, but you cannot apply this substitution to it. It can't work. It can't work. Such can work. And I'll be giving you the triangle for that, what is going to be on the hypotenuse, the adjacent, and what the sine, cosine, and then the theta is going to give you. All right. So as far as this question is concerned, then we are going to do the substitution of this. So please, all that you need to know is to know for this, for that, that, and that is all. Whenever the question is giving you, then straightforward, you start doing your substitution. So here by substitution, we can have this one. You know that we can write it the theta over this, alright? So here the theta, this is the same as, let me rewrite it. This is the same as theta over 2 plus cos theta the theta. Oh, sorry. Sorry. Alright. So the theta here is 2s. Is 2 ds over 1 plus. Now in some books, they ignore the s and use t. It's still the same thing. If you want to use t, no problem. But here we are using x. Alright. So the whole of this is the theta. That is what we have here. Then yes, you are just doing substitution. Yeah, that's it. And the rest is just algebra. Alright. 2 plus cos theta. Cos theta we have here is that 1 minus s squared over 1 minus s squared over 1 plus s squared. Very good. So that is exactly that we have there. Now, here can be sine, it can be cos. It doesn't matter. Alright? If it is sine, go for this. If it is cos, go for this. It's just substitution you're doing. The one that don't come in is silent there. So here we have 2 over, just algebra, 2 over 1 plus s squared. All this over. Now we are going to achieve the same denominator here. So we get 2, 1 plus s squared over 1 plus s squared plus 1 minus x squared over 1 plus x squared. Very good. I hope you can see that. Here, here, here. Now, with this, don't forget, if you want to take the derivative of this, don't forget this ds. So you can bring the ds here. This ds, you can bring it here. Now, don't forget that, you see, for you to take the derivative, sorry, the integral of the whole of it, then you die. It's like it's not in any of the form. So we have to simplify it to be in the least form, alright? So that is all that we are doing for now. Very good. Just watch me. When you meet similar, you do the same thing. So here, this time this, you get 2 plus 2x squared plus 1 minus x squared. Very good. All this over 1 plus x squared. The same denominator. Then you bring the ds here. Alright. Now the fact that here the ds is here and now you are bringing it here doesn't mean you are committing algebraic error. It's not like that. It's not an error. Very good. Now clearly you can see this will cancel this. It's clear. It's clear. And that is going to be left with 2 over. Now here, this to this, you get x squared. X squared plus 3 ds. Very good. You can see that we are getting it in the form that we can just integrate with ease. With ease. Very good. So, having such, are we getting rid of something? Alright, let me see. Is there any mistake somewhere? Oh no, there is no mistake. There is no mistake. Alright, let's continue. So here, we can now move on to integrate this. Now, if you want to integrate this, it's just simple, okay? Alright, you want to let it be in a form that you know. And we can factor these two out. 1 over x squared plus square root of 3. And watch me. You create the square root, then you destroy it. The reason is that we just know that here is x squared plus, and that means that the next thing should be something like a squared, so that we can get tan inverse. So you create the square root, then you destroy it. Hope you can see that. Very good. And when such happens, then you are going to get, I hope you haven't forgotten that. Let me write this 2. This 2 is already there. 1 over the a. The a is square root of 3. Then the tan inverse. The tan inverse of u over a. And the u is now x over the a. And the a is square root. I'm coming. Alright. And the a is square root of 3 plus c. Alright, so that is what we have, and therefore, when you rationalize this, you are going to get 2 square root of 3 over 3 tan inverse of s over square root of 3 plus c. So that becomes your final results for such. That becomes your final results for such case. Alright. But there is something that you need to take note. Don't forget that the question, we were not given the question in terms of x. It was in terms of theta. So for us to do the substitution and to integrate as respect to x, that is why we change it to this form and now take the integration as respect to x. So we have to bring it back. That is why you just not need to know only this, not only this, not only this, but also this. So half angle of what? Theta. Alright. So when you get this, then you continue to say that but S is equal to tan theta over 2. Alright. Therefore, by substitution, let me clean this back. Therefore, I hope it's cool. Therefore, by substitution, then we end up getting 2 over 3 square root of 3 tan inverse of S. And the S here is tan inverse, is tan theta over 2. And it's S over square root of 3. So you just multiply by 1 over square root of 3 plus C. So that is what we are going to get for that. Or you can leave it as 2 over 3 square root of 3 tan inverse of 1 over square root of 3 tan theta over 2 plus C. So this becomes your final answer. So please don't end with this. Know that you need to transform all your x's to theta. So that is all. Hope it's not difficult. I don't think so. Because when a question is given to you, and it's not in the form of what we have previously done, go back and watch that video and the examples. Then it means that you're going to apply the. Now, when a question is given to you, the question is not going to say that use the technique of tangent of the half angle substitution to do this. No, it's not like that. It just evaluates, and you need to know how to go about it. Know that the previous one, we don't have the case where you'll be having a constant there, you'll be having a tree function. It's never like that. It's always whether you're having sine or cos on the numerator, and or having both, and also the denominator. Sometimes it's all I think it's always, it's not I think, it's always sine and cos. Sine plus cos. Forgetting the constants there. Something like that. Very good. So that is that. That is all that I can say for that. And here you just do the substitution, the one that we just clean up. Just do the substitution, and when you do the substitution, you just simplify the inside, and you end up getting what you already know already. What you already know. So that you link up and go your way. Very good. Let's look at our second question, which is dealing with the half angle in the question. Alright, with the question dealing with the half angle. Now don't forget that in our previous question, the example 1, there is nothing like half. It was theta, or if I'm bringing it here, the argument we're using here is x, so it's supposed to be just x. Then if it's like this, then you can apply the idea down with it. Alright. And that one, you know that the substitution, the one that you bring, is in terms of x. So if the question is in terms of x, please, don't bring the one that is in terms of x, but rather change that to t. Or you can change that to any variable of your choice, whether y or whatever. Then you bring it to this side. Alright. So you know where that is going to be theta for you. So here we have it to be half x, and we are taking the integration as respect to x. That is why we have changed the right angle triangle to t, to t, to t, to t. Alright, it's still the same thing, just that here it's quarter. So when such happens, if you put t to be equal to tan x over 4, when you take the derivative, then you end up getting this. Alright, very good. And you end up getting that. So that is what you are going to have for that. Is there any mistake there? All right, so that is all. So let's just start and do the substitution. So here the ds here, the ds is what? Ds is giving us to be ahead. So the ds is giving us to be 4 over 1 plus t squared dt. All this over 3. The cos of the half angle is 1 minus 1 plus now this is 4 over 1 plus t squared. So here you want to achieve the same denominator. So one from this x. Sorry for that. Alright, it's supposed to be t, so that we take as respect to t. If something is not going on well, you need to know it. That's why you have to understand it. So that is just that. And for here we achieve the same denominator here. So I think that is it. Alright, very good. Very good. So integral of 4 over all this over 3 plus 3t squared plus 5 minus 5t squared. Then the same denominator. Let's cancel this. So we get 4 over. Now, this to this, you get 8 here. Then minus 2. Hope you are watching. 2t squared dt. Beautiful. And this is just going to give us 4 over integral of 1 over. Don't forget, you can factor 2 out so that we get 4 minus t squared. You are getting something. And that is the t. Alright. I want to remind you something important. And note that this one is a constant minus the variable square. And that is the integral of the constant square minus the variable square du. Just going to give you, that's just going to give you 1 over 2. It's like difference of 2 squares, okay? It's difference of 2 squares. And that's going to give you 2a multiplying by 1 minus, alright, that is u minus a, then u plus a. So don't forget that. So you don't need to go through all the steps in partial fraction decomposition. You can do that. You can do that. Because this is the same as 2 integral of 1 over 2 square minus t square dt. So Since this one a difference of 2 squares, you can do that, no problem. You can do that. That will be 2 minus t, 2 plus t. And that's going to give you partial fraction. You can go by that. But for shortcuts, then you go by this. So, with substitution, by substitution, this is just going to give you 2 multiply 1 over 2 times a. The a here is 2. Leave. So this is going to be t minus 2 over t plus 2. That's exactly what we have. So we can bring this up. And that is 2 over 4 to the t minus 2 t plus 2 plus c. So that is exactly what we are going to have. Let me confirm it here. Oh yeah. Oh yeah. So that is exactly what we are going to have. But let me do this correction. This one will rather go down. Sorry for that. Here is going to be plus, this one will be minus. Right? This is going to be plus, this is going to be minus. But you can still go through the process. You can still go through the process and you will be getting it. Think when you have the variable squared minus the constant squared. If you have something like this, that is when you are going to have, that is when you are going to have 8 in the form u minus a over u plus a. But for the constant square minus the variable square, that's going to give you t plus, the plus will go on top, then the minus will be down. And even the minus, here will be 2 minus t. Sorry for that. Don't forget to do the correction. 2 minus t. Alright. But if it's the variable square minus the constant square, oh, I'm giving you something. Alright. If it's the variable square minus the constant square, we have to take note of these things very well. If it's the variable square minus the constant square, you are going to get 8 to be in this form. But if it's the constant square minus the variable square, that is going to give you, you see with this, whether 2 plus t or 2 minus t plus is still the same thing. So this is the same thing. Alright, you can choose not to change it. Okay, so don't forget that the general forms of these things. Alright, so we end up getting half to the 2 plus t over 2 minus t plus t. So that is going to be the final answer for that. But you know what? After getting this, don't forget that we know that t is equal to, so back here, we need to bring back our s's. So back t is equal to tan s over 4. Then you go and do the substitution. Alright. So let's do that and close for this video. But I will give you some questions for you to go and try. So here we got half time. Sorry. You think I'm used to writing time in this. Leave 2 plus tan s over 4 over 2 minus tan s over 4 plus c. So this is going to be your final answer for that. You can choose to continue to simplify it, but I leave it to this side. Very good. So that is the final answer for our question. So I'm still reminding you to take note of these things well. If it is 1 over the variable minus the constant square, this is going to give you from a different of 2 squares, so 2a, then the need of u minus a, u plus a. But if it's constant square minus the variable square, that is going to give you the integral of it. That's going to give you 1 over 2a root of a minus, right? That is a plus u, then a minus u. Alright, so that is that. Be careful with that. Very good. Let me see if I can get you some questions for you to go and exercise your minds on it. Okay. Alright, so you are to go and try on this. Make sure you try on this. Here you have to find this. And now this giving you see, it's not in the form of what we previously done in our video. Knowing that here we go sign a series, we establish on that part that numerator can be only sign or sign plus cos or cos plus sign or only cos. But look at that one. We established that it can be whether it can be sine and cos. You have to see both sine and cos there. The one here you have to see both sine, whether sine theta plus cos theta, whether plus or minus, alright? So that's what we established on our previous video. And that here can be cos, here can be sine or whatever. But in this case, we are using the target of the half angle substitution. That's what we're going to use for that. And add by expressing the integral. I hope you know the integral. That is the integral function. By expressing the integral in terms of ratio of theta over 2. Theta over 2. What this means is that by expressing the integral in terms of ratio of theta over 2 means that when you are done with everything, make sure that you go and do the substitution back, right? Because yeah, you know that you are going to do the substitution. So after everything, you go and do the substitution back. That's all what is telling you here. And with this, by the change of variable, t is equal to tan theta over 2. And you know what that is also what it means. Alright. Very good. And with this, I would like to change this question to alright. So here, just find that and you know how to go about it. That is by doing the substitution of t is equal to tan t of s over 4. That is what we use to do this. Very good. So see you for our next video. Now in the next video, we are bringing you the last part of the last but one part of the techniques, and that is hybrid substitution. And after hybrid substitution, we get to mixture of roots. Then we are done with all the techniques under the course of integration. Thank you. See you in the next.